Hello, let's learn theorem of areas of similar triangles. If two triangles are similar, then the ratio of their areas is equal to the ratio of squares of their corresponding sides. Okay? As per this statement, we need a pair of similar triangles. Let's suppose there is a pair of similar triangles. Let their names be triangle ABC, similar triangle PQR. Okay? Let's mention given triangle ABC, similar triangle PQR. Then what to prove? To prove a ratio of areas of two similar triangles. Means here area of triangle ABC upon area of triangle PQR equals a ratio of squares of their corresponding sides. Means AB square upon PQ square equals BC square upon QR square equals AC square upon PR square. Okay. At the beginning of this chapter, we learnt about ratio of the areas of two triangles, and that is known as property of ratio of areas of two triangles. That property tells us the ratio of areas of two triangles is equals ratio of products of their bases and corresponding heights. That is A1 upon A2 equals B1 into H1 upon B2 into H2. There we consider two triangles, not necessarily similar. They may be similar, may not be similar. In that case, ratio of their areas equals ratio of the products of their bases and corresponding heights. Means there we consider bases as well as their corresponding heights. Okay, we are going to apply that property of ratio of areas of two triangles here. And to apply that property, we need bases as well as heights. Okay, for that, let's start a proof. Let's start with the word let. In a triangle ABC, AD perpendicular BC, and in a triangle PQR, PS perpendicular QR. Okay. Why we are considering AD perpendicular BC and PS perpendicular to QR? Because AD will work as height, BC will work as base, QR will work as base, PS will work as height. Okay, and therefore, by that property we may mention area of triangle ABC upon area of triangle PQR equals BC into AD upon QR into PS. Let's call it as equation first. Since property of a ratio of areas of two triangles. Okay. Actually what happened here, half into BC into AD upon half into QR into PS, half get cancelled, and due to that we got BC into AD upon QR into PS. But triangle ABC is similar with triangle PQR since it is given, and therefore angle ABC congruent angle PQR, since corresponding angles of similar triangles. Okay, let's denote these angles by identical marks. That is, angle B is congruent with angle Q. Let's call it as equation second. Then also we may write what? If two triangles are similar, then their corresponding sides are in proportion. Means here AB upon PQ equals BC upon QR equals AC upon PR. Let's call it as equation third. And therefore, in a triangle ABD and a triangle PQS, we may say angle B is congruent with angle Q. From second, angle ADB congruent angle PSQ, since each 90 degree. Okay, two angles of one triangle are congruent with two corresponding angles of other triangle, and therefore triangle ABD is similar to triangle PQS by AA test of similarity. Okay, and therefore if two triangles are similar, then their corresponding sides are in proportion and corresponding angles are congruent. Let's mention here AB upon PQ equals AD upon PS equals BD upon QS. Let's call it as equation 4. Since corresponding sides of similar triangle, here also we may mention since corresponding sides of similar triangle. Okay, and therefore from 1, 2, 3 and 4, equation 1 tells us area of triangle ABC upon area of triangle PQR equals BC into AD upon QR into PS. Let's split bases and heights. Means BC upon QR into AD upon PS. Okay. Now equation third tells us that BC upon QR equals AB upon PQ. Equation 4 tells us AD upon PS equals AB upon PQ. Okay, let's replace BC upon QR by AB upon PQ into AD upon PS by AB upon PQ. Okay, and therefore AB into AB gives us AB square, PQ into PQ gives us PQ square, and therefore area of triangle ABC upon area of triangle PQR equals AB square upon PQ square. Equation 5th. Similarly, we can prove that. What can we prove? Area of triangle ABC upon area of triangle PQR equals BC square upon QR square equals AC square upon PR square. If we call it as equation 6, and therefore directly we may declare a ratio of the areas of two triangles means area of triangle ABC upon area of triangle PQR equals AB square upon PQ square equals BC square upon QR square equals AC square upon PR square. From 5 and 6. Hence the proof. Okay. Now this theorem we may extend like what? The ratio of areas of two similar triangles is equals ratio of the squares of their corresponding sides. Okay. And we know that if two triangles are similar, then their corresponding sides are in proportion. Isn't? And as here is a ratio of the squares of corresponding sides. Similarly, if two triangles are similar, then their corresponding heights are in proportion, their corresponding medians are in proportion, and their corresponding perimeters are also in proportion. That's why ratio of the areas of two similar triangles is equals ratio of the squares of their corresponding sides, or ratio of the squares of their corresponding heights, or ratio of squares of their corresponding medians, or ratio of the squares of their corresponding perimeters. Okay, we may verify. How we can verify? Here, we replace BC upon QR by AB upon PQ. Isn't? Similarly, AD upon PS by AB upon PQ. Okay, now BC upon QR equals AB upon PQ, and AB upon PQ equals AD upon PS. Isn't? If we put here at the place of BC upon QR as AB upon PQ, and again AB upon PQ equals AD upon PS, then AD upon PS into AD upon PS will give us AD square upon PS square, where AD and PS are their corresponding heights. Means ratio of the areas of two similar triangles is equals ratio of the squares of their corresponding heights. Okay. Similarly, we may prove ratio of the areas of two similar triangles is equals ratio of the squares of their corresponding medians, and ratio of the areas of two similar triangles is equals ratio of the squares of their corresponding perimeters. Let me mention here. Number one, the ratio of areas of two similar triangles is equal to the ratio of their corresponding sides, or is equal to the ratio of squares of their corresponding heights, or is equal to the ratio of squares of their corresponding medians, or is equal to the ratio of squares of their corresponding perimeters. Okay, that is, if triangle 1 similar triangle 2, then area of triangle 1 upon area of triangle 2 equals S1 square upon S2 square equals H1 square upon S2 square equals M1 square upon M2 square equals P1 square upon P2 square, where S1, S2 are corresponding sides. Okay, H1, H2 are corresponding heights, or we may say altitudes. M1, M2 are corresponding medians, and P1, P2, P1, P2 are corresponding perimeters. Okay. Thank you.